Now talking about the stereoisomers of alkenes. So the stereoisomers of alkenes come under the class of the configurational stereoisomers. Configurational stereoisomers means that they cannot interconvert at room temperature. That means they are completely two different compounds. They can exist at the same time, but when they exist at the same time, then that means we have two different compounds that we can separate from each other. The stereoisomer from alkene come from the different arrangement of the different substituents around the double bond. So we will only have stereoisomer of alkenes when we have different substituents around the double bond. So an example of that, if we have an alkene like this one, so we only, when we are looking at the stereoisomers, we only looking around the double bond. Okay, so this is a double bond here, and this double bond has two different substituents, has an R, and of course it has a hydrogen here. The other carbon as well has an R and has another hydrogen here. That means it has two different substituents on each carbon. And now this two R are arranged in the same position in relation to the double bond. They are on the same side of the double bond, these two R groups. So we call this alkene as cis. This is the same alkene, but now the two R groups are on different sides because we still have the two hydrogens. So the two R groups are in two different and opposite sides, one on that side and the other one on the other side. This is called trans, which means opposite side. So when you have two alkenes that have two substituents, 1,2 substituent, when I refer to 1,2 here, I refer to the two carbons of the double bond, not to the whole compound, because the double bond may be on position 4 for the alkene, position 5. It doesn't matter where is the double bond. I'm just talking here about the double bond itself, as if it's an ethene. Okay, so when I say 1,2 di-substituted, I mean here one is the carbon number 1 in the double bond, and the 2 is the carbon number 2 in the double bond. So 1,2 di-substituted ethenes, or 1,2 di-substituted alkenes like this one. So it can has the, if I only have one substituent at 1 and one substituent at carbon number 2, then we can call it cis and trans. But if I have more than two substituents, if I have like another group here and it has to be different from this one, so if I have a chloride here, for example, then I have more than two different substituents, then I will call this Z and E. I'm not going to refer to it as cis and trans. E, when we have the two groups which have the priority at the same side, will be Z, and E, when I have the two groups which have the priority on the opposite side. This looks a bit ambiguous, so let's explain what is this priority. What do I mean by priority? So when we're talking about the di-substituted ethene we drew here, so you have C double bond C with two R groups like this, and hydrogen. We gave the substituents, which is the R group here, the priority over the hydrogen. Okay, so this is why we call this cis. So if I have something like chloride now instead of the hydrogen, will this be Z or will this be E? I cannot actually say now because here the R was given priority over hydrogen. What about this R here, this R here, and the chloride? Which one will be given priority? So there is a certain rule I can follow called the Kahn-Ingold-Prelog rule, or CIP rule. This rule will help me to find the priorities of the different substituents around the double bond. So I look at the priority for the different groups around the groups attached to the first carbon here. So I will include priority for these two groups together, and separately I will look at the priority for the groups attached to the second carbon, so these two groups together. So Let's look at these rules in order to know how to assign the priority for the different group. The first thing I will look at is to order them in by atomic number. So if you have two substituent, one is chlor and one is carbon, like a methyl group, then I will give the chloride a priority over the carbon, because the priority, depending on the atomic order, you have the chloride has priority over fluoride, which is higher in atomic number than oxygen, which is higher than nitrogen, which is higher than carbon, and carbon is higher than hydrogen. So the first thing is to order them by atomic number. The second thing is to, in case I have two isotopes like deuterium and hydrogen, they are still two different, I consider them as two different substituents. And now I will order them in by mass. So deuterium has higher mass than hydrogen, so deuterium will have priority over hydrogen. So this is the first thing. So if you have a double bond like here, and you have a chloride here and a methyl group in here, and I have hydrogen here, and let's say I have a methyl group here, would this be a Z or E? So I would look at the first carbon first. So carbon number 1 here. So which one will have priority? Which one will have priority? We have a methyl and we have hydrogen. So I will give the methyl priority. So this is going to have the priority. Okay, so carbon number 2. Carbon number 2, I have chloride and I have methyl. Which one will have the priority? So the chloride will have the priority. So now I have the methyl and the chloride for the two carbon atoms will have the priority, and they are on the same side. So this is going to be an Z, because Z means the two groups with the highest priority are on the same side, and E means they are on opposite side. Okay, so this is the first one, is to order by atomic number, and then in case of isotopes by mass. The second rule here says that if you have the same priority at the first atom, then go to the first point of difference. What does it mean? So let's say that I have this double bond here, and I have an ethyl group here, CH2, CH3. Okay, let's say this is a chloride and hydrogen. And then here I have CH3, CH3, and hydrogen. Okay, so when I look at carbon, the first carbon, it's so easy because I have a chloride and hydrogen, so the chloride will have the priority. Okay, so this is assigned, so I don't have any problem with that. What about the second carbon here? Carbon number 2. So let's look. So here there is a carbon here, and there is a carbon here. Okay, so there is no difference, they are the same. So now I have to go further in my structure to see where is the first point of difference. So this carbon is attached to, this carbon here is attached to two hydrogens and one carbon. So the three other bonds that this carbon has are two hydrogens and one carbon. While the other carbon at the bottom here, this carbon has two carbons and one hydrogen. So the first point of difference will be the second carbon attached here, because this one has hydrogen, 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 and methyl or a carbon, but this one has hydrogen, carbon, and carbon. So this hydrogen is the same like this carbon is the same like this one, and then this one has a hydrogen and this one has a carbon. So the carbon here will be the first point of difference. So it's the second carbon in the chain for the substituent. So this group at the bottom here will have the priority in comparison to the top one. Now we have the two groups which have the priority at the same side as well, so this is going to be Z as well. Okay, so Another example, if I have something like CH2, CH2 and SH, and the other one CH2, CH2, S, CH3. So the first point of contact CH2, the other one is CH2, the second one CH2, the third one CH2, the following one is sulfur, and this is sulfur, but now the sulfur is attached to hydrogen, but this sulfur is attached to a carbon. So this one will have the priority. So this is the first point of difference. So the first point of difference doesn't have to be the atom that is directly attached to the sp2 carbon or the carbon with the double bond. It can be anywhere along the series or along the substituent. Another one is this one down there. So this one has the first one is a carbon and this one is a carbon. But look, this carbon is attached to two hydrogens and one carbon. This carbon is attached to one hydrogen and two carbons. So the first point of difference is actually going to be this carbon, which is different from here, which has two hydrogens. So this group will have priority. Even though we have an oxygen here, we don't look at the whole group as it is. We just look at atom by atom and we look at the first point of difference. Another one is this one. Okay, so you have the first point here is CH3, is a carbon, and this is a carbon, but this carbon is attached to two hydrogen and one carbon. This one is attached to a hydrogen, deuterium, and carbon. So now that deuterium has priority over the second hydrogen here because we give it priority by mass. So this one will have the priority. So this is how you assign the priority. There is also a third rule for how to establish priority between substituents. So if you have double bonds, so let's say that you have something like this one attached to a double bond in a diene. Okay, so you have two substituents, right? So one of them has this double bond. When you have a double bond or multiple bond, whether it's double or triple, then the representation of atom will be the respective other end of the multiple bond. What does it mean? If this is a double bond here, then we will consider each of these as a single carbon atom. So this carbon here, carbon number one here, okay, this carbon as if it's attached already to two different carbons, 1 and 2. And the second carbon, this one, is also attached to two different carbons, which is this one and that one as well. So now when I draw this double bond, I will consider as if it has two different carbon atoms. So I will uh, revert it back as if it's attached to different carbon atoms. I'm not going to deal with it as it is. So I have to revert it back to the different connections to the as if it has different connection, not connection with only one atom. If it's triple bond, like this one, so I'll consider the first carbon, this is the first carbon, as if it's attached to three different carbon atoms, 1, 2, and 3. For the second carbon, this one, it's also attached to three different carbons. So it's one carbon, two carbon, three carbon. And then I would look at the first point of difference. What if I have something like C double bond O? So if I have something like C double bond O, then I also will consider like this carbon is attached to oxygen. So the carbon here is attached to oxygen. So carbon is attached to this oxygen and that one, and the oxygen as if it's attached to two carbons. So attachment of the oxygen will be this carbon and that carbon. Now I would look at the first point of difference. C triple bond N as if the carbon is attached to three different nitrogen and the nitrogen attached to three different carbons. So this is the carbon and these are the three nitrogens, while for the nitrogen it's attached to three different carbons, 1, 2, and 3. So I have to put it back as if it has different attachment. Then I would look at the first point of difference. Let's have some examples. And I hope I didn't really confuse you with this double bond and the multiple bond rule. So let's have an example. For example, if we have this first alkene in here, I have two carbons. One is labeled yellow and the other one is labeled red. So I start looking at the yellow first, the substituents that are attached to the double bond. Now I'm looking at this double bond to assign the different substituents into Z and E. Okay, so it's the yellow carbon is attached to methyl and hydrogen. So we know that methyl will have priority over hydrogen because methyl starts with carbon, which has 3 hydrogen atoms, and carbon has priority over hydrogen, so the methyl will be given the priority. Then on the other side, we also have a methyl and hydrogen. The methyl will be given the priority over the hydrogen. So now I look at the two groups or two substituents which were given the priority, whether they are on the same side or on opposite sides. So the two methyls are on the same side, so this is a Z. What if I have the opposite one, so the other one? So I have the methyl here for the yellow on that side, because they're the methyl and hydrogen. On the red carbon, I have hydrogen and methyl is given the priority, but the two substituents on the two carbons are on opposite sides, so it's going to be an E. The following one, this one here, so the first carbon, the blue one here, it has hydrogen and it has deuterium. Deuterium is given the priority. Okay, so the second carbon, the red one here, it has hydrogen and methyl is given the priority. The two groups which are given the priority are on the same side, so it's a Z. The other one, I have the red carbon here, it has deuterium and it has methyl. Methyl is given the priority, so methyl will be the one that is given priority. The second carbon, which is blue, it has a hydrogen and the methyl is given the priority. So the two groups which are given the priority are on opposite sides, so it's going to be E. The last one, again, look at the first carbon, the blue now. There is a bromide and chloride. Bromide is given priority. The other one, the other carbon, the red one, it has hydrogen and methyl. Methyl is given priority over hydrogen, so it's going, and the two groups which are given the priority are on opposite sides, so it's an E. Another set of examples. So this is that I need first to look at the double bond. So this is my double bond. Let's assign our priority. So for first carbon, the blue one here, okay, you have this propyl and you have this methyl. Which one will be given the priority? Now, when we think about the first point of difference, you will definitely think, yes, it is the propyl group. So this is given the priority. Now the second carbon, red one, it has a methyl and it has an ethyl. Which one is given the priority? It's going to be the ethyl group. Now the two groups are on opposite sides, so this is an E. The second one, again, first carbon, which is blue, it has here, this is an isopropyl group, so there is a carbon here and there is a bromide. So which one will be given the priority? Is it the carbon or the bromide? Because I look at the first atom. I don't look at the whole group. Don't look at the isopropyl and the bromide and then compare. You don't compare like this. You compare atom by atom. So the first atom is attached, which is attached to the carbon here. The double bond is here is carbon and here it's bromide. So bromide is given priority over carbon. The other on the other side, the green one here it's a methyl, so there is a carbon here and there is an oxygen, and we know that oxygen has a priority over carbon, so this will be given the priority. Now both groups which were given the priority are on the same side, so it's going to be Z. The third one, so again, first carbon. Okay, so let's look. There is an ethylene group here, and there is an ethyl group here. Let's look at the first carbon attached. So there is a carbon here, and there is a carbon here. So there is carbon here, and there is carbon here. But now this carbon, because it has a double bond, so see that has a double bond, we will put it back as if it has different attachments. So we will consider this carbon as if it's attached to two different carbons. Okay, and this carbon only attached to two hydrogens in addition to the third carbon. So this one is attached to two carbons, the double bond, but the one with a single bond is only attached to one carbon. So this one will be given the priority. Now looking at the other one. So again, we have the same group here with the double bond, and we have the phenyl group. Okay, so this one, let's try to assign the priority. Let's look at the different attachments. So the first one, this carbon is considered as if it's attached to two carbons. This carbon here is actually attached to one, two, three. So as if it's attached to three different carbons. So which one will be given the priority? It's this one that's attached to two carbons, because this one that at the bottom here is attached to two carbons and a hydrogen. So the phenyl group is given the priority. So now the two groups which have been given the priority are on the same side, so it's an E. So it's a Z on the same side, so it's a Z. Now this last one, have a look at the first carbon. Okay, so the first one, it has two groups, CN, which means C triple bond N. So we will consider this as carbon attached to three nitrogens. And this is a phenyl group, so this carbon is attached to three carbons. So which one will be given the priority? So the first carbon is the same here. There is carbon here, and there is carbon here, but the carbon is attached to nitrogen, and the carbon here is attached to carbons. So nitrogen is given priority over carbon. So and this is going to be the first point of difference, so the cyano group will be given the priority. On the other side, you have hydrogen and methyl, and we know that the methyl is given the priority. So looking at the two groups that have the priority on the both sides of the double bond, we will find that these two have priority on opposite sides. The two groups which have the priority are on opposite sides, so it's going to be an E. This is how to assign the different stereoisomers of alkenes. Remember that we only use cis and trans if we have only two substituents, one on each carbon of the double bond. But when we have more than two substituents, then we use Z and E. Cis and trans, we can also use Z and E when we have only 1,2-di substitution, but we cannot use cis and trans if we have more than two substitutions.